session. So for this week, we are going to be walking through algorithms and pseudocode, callbacks, and pull requests. This session is meant to be like a small introduction to these new concepts. So I will try to keep everything as easy as possible. And here's the agenda for this session. So our session today will be kind of like split into two parts. So part one will be the plan, where we will talk about what an algorithm is and how pseudocode helps you plan your logic before you write actual code. Part two is the execution, where we will look at callbacks and then collaboration through pull requests. Try to think of part one as like planning your solution to solving any problem. And then part two is going to be about actually bringing that solution to life and learning how to share work with others. So what first, let's understand what an algorithm is. So an algorithm is nothing but a simple set of instructions that are used to accomplish a specific task. To be effective, it must possess three key characteristics. Uh, the easiest way to think about algorithms is like a recipe. A recipe gives you clear, order, and finite steps to turn ingredients into a finished dish. And an algorithm works the same way for a computer. And then, uh, and then when I say that algorithms should be clear, it means that each step should be precise and easy to interpret. Second, it should be ordered, meaning that the steps should happen in a logical sequence. And then when I say finite, that I mean the process should have a finite number of steps and it should not be able to run forever. So anytime you solve a problem step by step, you are almost thinking in terms of algorithms too. And when you think about it, you are using algorithms everywhere. The simplest example that you can think about is making a sandwich. So, what are the steps for making a sandwich? Like a simple peanut butter and jelly sandwich. So, first of all, you would prepare the ingredients. In this next step, you would spread the peanut butter and the jelly, and then you would assemble the sandwich. That sequence itself is your algorithm because it gives you ordered steps to reach a result. And then on the right side, you can notice that there is also a decision. If some people prefer their sandwiches whole, while some people prefer it cut. So if you want the sandwich cut, then you slice it diagonally or you slice it vertically. It depends on what kind of slice you want. If not, you could just skip that step and enjoy your meal. That is just a simple example of conditional logic inside an algorithm. So, algorithms are not just used in programming, we actually use them in everyday life anytime we decide to follow a process step by step. And that the next idea building on that would be pseudocode. Now, I guess some of you have already heard about what pseudocode is, but for those of you who haven't, pseudocode is just a plain English description of your program steps. It helps you focus on the logic of solution without getting stuck on the syntax or worrying about the exact programming language right away. A good way to think about pseudocode, it's like a blueprint. Just like how an architect plans a building before construction starts, a developer can plan the logic before writing the actual code. And then, if we look at this example on our right, we just have a simple tip calculator. We start the program, ask the user for the bill amount, and then ask for the tip percentage. Once we get both those numbers, we calculate the tip by multiplying the bill amount by the tip percentage divided by 100. That gives us a total by adding the bill amount and the tip. And then finally, we display both the tip and the total, and then the program ends. So, pseudocode is really about a way to organize your thoughts and approach before you write real code. So that is why I would always recommend that is why I would always recommend writing your approach in pseudocode plus before you start programming. And now let's take another look at let's take another look at another simple example. So there's only just one simple question that you need to ask before stepping out. Like, do you need an umbrella? And then to consider this particular question, there are only two one input to consider. There's only one input to consider, and that is it raining outside? And the output is nothing but a decision either to take an umbrella or not. And then here is that particular the pseudocode just walks us through the logic. We first start, we check a condition. If it is raining outside, we decide to take an umbrella. Or else, if it's not raining, we don't need an umbrella, and then the program ends. So this is a simple example of how pseudocode helps you map out the decision making process before writing actual code. Does that make sense? Or and I just wanted to pause real quick and see if anybody has any questions so far about what we've discussed so far. All right. So if there aren't any question, so we can just move on to the next concept, which is callbacks. Now, what is a callback? A callback is simply a function that is passed on to another function as an argument, and then it is executed later when a task or event happens. A simple example is like ordering coffee at any cafe. You give the barista your name, and then you wait. And once your coffee is ready, your name gets called. That is the same way a callback function works. It waits until a certain event happens, and then and then the callback function runs based on the event. And then on the right, we have a small example where we just first select the button from the HTML using the document.query selector. If you don't know what that is, do not worry. This will be explained in the coming weeks. Then we create a function called handle button click, and inside that function we show an alert message, and then finally we use an event listener to tell JavaScript to listen for a click event on that button. And when the button is clicked, that's when the callback function, which in this case would be the handle button click, would run. So the main idea is that the function does not run immediately. It runs later when the event or condition happens. So now let's take some time to consider. Now let's try to understand why callbacks matter. So the first thing that always comes to mind is reusability. Callbacks let you create flexible decision functions that can perform different actions depending on the logic that you pass in. And then another reason why callbacks matter is to execute asynchronous operations. They help you handle delays. Like there could be some scenarios where you would be waiting for data from an actual server without stopping the rest of your application. And another reason why callbacks matter is event handling. So callbacks are a core part of establishing interactions on the web, like button clicks, form submissions, and other user actions that can be executed on the website. And then on the right here, we have a simple function called log result, that simply prints a result to the console. And then we have another function to add numbers, which takes like two numbers and a callback function. And then inside that function, we just simply calculate the sum of the two numbers. And then deciding what to do with that sum directly, we just pass it into the callback. And finally, when we call the add numbers function, with JavaScript adds, for example, 5 and 10, and then sends that value into the generic function that we had provided earlier, which thereby would print the result as 50. So this is what makes callbacks powerful. One function can do the main job, and another function can decide what happens to the result. And now let's talk about pull requests, or you may often hear them as PRs. A pull request is one way about how developers collaborate on a shared code base in a structured and safe way. A simple way to think of it is like a formal peer review for your code. You're basically making a request that to your team to review your code, review your changes before those changes are added to the main project. And then, so the step one for this particular for a PR workflow would be to create a branch. This means you are completely isolating your work from the main code base as you can make changes safely. Once you make those changes, you can commit those. This is where you would save your progress with clear and meaningful commit messages. And then once you have made the commits, the another step would be to open a pull request. This is where you can propose your changes for review, and then fine. And then the last step is review and merge. So this is where some teammates would look over your work, leave any feedback if needed, and once everything looks good, the changes are merged into the main branch. So the main purpose of a pull request is to make collaboration safer, cleaner, and easier to review. Okay, so that brings us to a quick recap of what has been covered so far. So first, algorithms and pseudocode help us plan our logic before writing code, which saves time and reduces bugs. Second, callbacks help us handle user events and asynchronous action, which makes our code more interactive. And then finally, pull requests give a professional way to collaborate, review code, and keep the main branch stable. And then to take a quick look of what happens next, we there of course there these methods can be explored as well, but this is where in the coming weeks we will be also taking a quick look at what HTML to the basics of HTML, and the week after that we will be taking a look at the basics of CSS as well. So both those courses would be both those weeks could be a bit heavy. So I would recommend trying to read up on some material before you join any of those sessions. That's just a recommendation, but these concepts will still be covered in class. Okay, so do you have any questions so far about the presentation that we just went through? Okay, if there are no questions, we can just move into the coding examples that I have set up for this particular session. Give me 1 second while I reshare my screen. Okay, I hope everybody is able to see the screen. Can anybody let me know if the screen is visible?
The screen is visible.
Okay, thank you so much for the acknowledgement. So let's just start us off with a very simple step-by-step solution of the peanut butter and peanut butter and jelly sandwich example. So what I'm gonna do is I'll just declare the number of slices of bread would be two, and we could say that there is some peanut butter, and also say that if there's peanut butter and there's jelly too. So one way of just figuring out uh, and to make a peanut butter and jelly sandwich, we would basically need uh, two slices of bread at the minimum, at least. And then what we can do is we can just check if bread slices of bread are greater than equal to true, and we can just check if peanut butter exists or not. The double ampersands represent the logical and operators. This can be used to check for multiple conditions in the same if statement. So if we have everything, then we can go ahead and make the sandwich. Or else, what we can do is we can just let the user know that you do need some ingredients. So this right here is the this like a first example of how you can check for it's just the simplest example of an algorithm that you could ever see. They will have like different slices of bread, and you will always check for peanut butter and jelly. If all the ingredients are there, we can make sandwiches, or else there will be some missing ingredients. So let's just try to run this real quick and see what the output is. So as you can see, since all the conditions are really satisfying, we can see that all three conditions are true. And then let's try to see if we try to change one of the values to false. What do you think would happen if that happened? If one of the values are changed? Yes, exactly. So since I've changed jelly to false, and and if I run the program again, you will the output changes to missing ingredients just because one of the required conditions is no longer true. Now, This right here is a good example of conditional logic. So if every required condition is true, then one block runs. Even if one condition fails, the other block would run. So And so this is how and now while we look at the next problem, we can try to write up some pseudocode for a trip. And this is how the pseudocode turns into real JavaScript. Like we discussed like this, the steps in the presentation, and then we translated those steps into variables, conditions, and outputs in code. Now, let's try to look at another example where if we had to like write some pseudocode for this, this is how it could start, and then we could try to set the bread slices, and then we could just see whether if peanut butter is available, and at the same time we can also check if jelly is available as well. And then once all the conditions are set, uh, if all ingredients are available, you could always display like make the sandwich, else display missing ingredients and end. So this is one way of writing pseudocode when it comes to problems like this. And then start would always mean that the start of the algorithm. And then we check for different conditions. Like in this case, we'll be checking for bread slices. And we just check if all the ingredients are available. Then we display make the sandwich. Display is kind of like the console log statement in this case, and then we have set different conditions as well. So this is sort of like how you would plan to implement this code, and excuse me. So this is how you would plan the solution before moving to JavaScript. Now, let's try and see whether we can start with the pseudocode for the tip calculator example that we can see. Just give me one moment while I set up the code. Okay, so for the calculator, what we can do is, of course, we can just start. And can anybody tell me what the next step would be? Yes, exactly. We would be getting the bill amount right here. So that would be one way to set the bill amount. Let me just make sure the above code is commented so that there's no confusion. Then, along with the tip bill amount, we will also get the tip percentage that you would need to calculate the tip. And then once we get all the input parameters, that is where we will start to calculate the tip amount. And then once the tip amount has been calculated, we can just calculate the total by adding uh, adding the bill amount to the total amount. And then once the total has been calculated, we will just be displaying that and seeing what we will be displaying not just the tip amount, but the total amount as well, just so the customer is aware about how much the tip would amount to. And just like that, we just came up with the to pseudocode to set a to come up with a small tip calculator that can be implemented very easily. So now let's try to convert this pseudocode into actual working code. So for the start, we will be setting the bill amount, which would be, let's say, 100. And then the tip percentage that we would be giving would be somewhere, let's say, 15%. So the way to calculate tip amount would be to multiply bill amount into tip percentage, and then we will divide this as the whole by 100. And once we get the total tip amount, we can calculate it by simply adding it uh, to the overall bill. And then once we get both these amounts, we could just console log these. And let's see, the tip amount is this, which would, and then we would also try the console log statement. We would just get the total amount, which includes the tip. And then, so this is exactly how we have converted this particular pseudocode into JavaScript. Let's try running this and see what the answer comes out to. Now, always remember to save your changes and make sure that all changes are reflected as well before you try to run this particular program. So again, pseudocode just gives us the plan, and JavaScript turns that plan into somewhat of the actual implementation. So if the bill amount is 100 and the tip percentage is 15, then the total amount would become 115. Uh, yeah, so this is how a simple tip calculator would look like. And now let's just say if I want to change any of the numbers right here, if I wanted to change the bill amount to say 2000 and the tip to be somewhat like 30 or 33%. So if I change this and run it again, the logic would stay the same, but the output would change. That shows why using variables is always useful, because we can always reuse the same algorithm with different inputs. And as you can see, even after changing uh, so the logic would stay exactly the same. And just because the input values change, the output change too. And that is the India. That would be the entire uh, this particular example. So now, since we've taken a look at algorithms and pseudocode, let's take a look to and let's move to a simple callback example for this particular. And then now, and then let's just try to look at the callback example that we had seen in this particular presentation. Uh, some of you may remember, some, and in case some of you don't, this is where we get to see those that particular callbacks get implemented in real life. So this is the callback function for just setting the result. The result would be this. And then this function defines a function that would accept just one value. And let's just define a function to add numbers. Should be numbers one, numbers two, and the callback and the callback function. It defines this function would be take like two numbers and one function parameter. And let's just try to implement that particular function. There would be a sum variable which would take in those two numbers. And then we could just call back this particular function while passing the sum. And then once we try to implement this, you can see that we would be passing the numbers 10 and 18, and it is also important to pass the function which would be displayed to show the result. And now once this algorithm is run, we can see the results being called back immediately. So let's see what happens. Okay, so this is one particular exam. As you can see, the result comes out to be 28. And so the main work is being done by the add numbers function because it creates another function that takes two numbers and one callback function, and then source numbers are added together in the add numbers function, and hence and then the log result function handles what exactly has to be done with the answer. So that is the core idea behind callbacks. Also, the callback is not really being called immediately on its own. It always runs when this add number function reaches this line callback sum and then passes the result into it. Now, if I had to set some conditions, like if sum is greater than 30, and then you should just implement the callback function. If we try to set something like that, you will see that there will be no callback functions being called at all. And there will be the one this setting conditions is one way to adjust for different behavior because the callback will only run if the condition is true. So this shows that a callback can also be controlled by conditions. Passing a callback function does not give like a complete guarantee that it will run. It will still depend on the logic inside the function. So let's say if let's try and change the inputs just to see how like try to change this 10 to 20, and then so the sum would come out to be 38, which will be greater than 30, and this time the callback will run and we will see the result get printed again. Okay, and now as expected, the result is 38. And since the sum is greater than 30, the callback runs. So this version shows two important ideas at once. So first, it helps us understand how callbacks work, and secondly, how conditions can control when a callback is executed. And with that, we have seen a basic example of like algorithms, pseudocode, and callbacks in actual JavaScript. So I'll just take a moment here to see if you guys have any questions whatsoever about the examples or maybe the presentation, or is there something else that you would like to see? What is the difference between callback and return? So that's actually a great question. So a return sends a value back from a function, while a callback is a function that gets passed on to another function to be used later. So let's say if I had to define this add number function into the number right here, which takes into numbers, and then if I just return a plus b. So here return will always gives back, uh, it would always give back the result back immediately. But if I try to implement this particular function, instead of return the value directly for us to use outside, the result is passed on to another function. So if I had to sum up the distinction in one line, the return gives us back a value, while a callback tells the program what function should handle that program, that value. So I hope that makes sense. See, okay. S- Okay. Are there any more questions? Okay. So it does look like we have time. So I'll just quickly move. I'll just show you guys real quick how to set up a pull request for your GitHub repo. And let me just, I need to share the whole screen for that. Okay, so this is the GitHub repo in which I will be uploading my examples for today, and I just wanted to show how you would do. So right now we are on the main branch. So the first thing that you would always do is create a new branch. So just check the status real quick. And then you can see that there have been some changes that are not staged. But in order to to avoid like adding those changes directly into main, a good practice should always be to create a new branch. And so let's say this branch is lesson 4, and then uh, we will add all of our files that are linked to the staging area. And once those files are added, just check whether those files have been moved to the staging area. Once they've been moved, you can just commit them with a message that says added algorithm examples. And then once the commit has been made, you can just push it on to the GitHub repo. And now since I didn't set any branch right now, so this is exactly why we can just set up this is just a one-time command that you have to set. And the branch since the branch exists locally, but it has not been linked to any remote branches on GitHub yet, so that is why we run this one-time command to make sure to just let GitHub know that this is one of the branches that we can push into. And let's see what happens. Okay. So this usually means that this particular line means that the setup stream links the local branch which we created to a remote branch. Uh, I'm sorry, could you please go keep yourself on mute?
Aquí dice que no, mira, síguele.
No, but did you ever sign up for anything?
No, 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 no es primer día hoy.
Yeah, exactly. It was not on.
Okay. Okay, so as I was saying, origin was the default name of the remote repository, and since the lesson 4 is the branch name, so let's see what happens after refreshing right here. So since I've just pushed, you can see that there have been other branches as well. Let's try refreshing that. And now, if you ever come across a yellow banner here, that means that your push has been successful and GitHub has detected new changes. So once you click the compare and pull request, this is where you would take a look at the changes that you just added. And you can just add a small title over here. It could be the same as the GitHub message that it's really up to the purposes of the project. And then once you come across this green button called create pull request, this is when it will be sent for review within your peers. Now since there's also one thing to make sure is to always check if there are any conflicts with the base branch. And now since there are no conflicts with the base branch, that means the changes that you added can be merged automatically. And once you click on the merge pull request button is the next step if you ever wish to push your code. And then once we confirm the merge right here, this is where you can see that the changes that we did in lesson 4 have been added right here. So this is how you essentially create a pull request. And so this means that the changes from lesson 4 are officially added to the project. And then so this is how you always make a pull request: create a new branch, make your changes, stage and commit them, and then push them to the branch on GitHub. And once they've been pushed, open a pull request, and then you can just review and merge it into main. Now, since this was the file that we were working on, it's on the main branch. It gives us visual confirmation that the merge was successful. So that was a quick end-to-end look on how to plan your logic, turn into JavaScript, and then share that work using Git and GitHub. Are there any questions so far about the demo or any of the concepts that we've covered in the presentation or the coding examples? Okay, let me just stop the recording right